Hello and welcome to another Allsolve tutorial. Today we'll see how to work with the GDS file format. When we create a new project in Allsolve, users are provided with certain options. The users can either create a CAD model directly using primitive geometries provided here and then applying Boolean operations on them, or they can upload a geometry file. And we can see here there are two file formats that are supported. One is the step file, the other is the GDS format. So the step file is the most common and familiar CAD file format used by many industries. But what is a GDS format and what does the file contain? So the GDS file format is predominantly used in semiconductor and MEMS industries. And in this file format, the geometric data is represented in a 2D planar layout in a hierarchical form. So for this tutorial, I have considered a MEMS device, particularly a MEMS accelerometer. I'll first open a GDS file format in KLayout, which can view such a GDS format. So I have KLayout here and I'll open a file that ends with an extension of GDS. So the MEMS accelerator looks something like this. And on the right hand side, we see information about the different layers and its corresponding layer numbers. So we have a substrate, which is layer number 63. And we also have some comb drives. So we have fixed comb drives and movable comb drives. And on the left and right, we have anchors on which the whole MEMS device is supported. And at the center, we have a proof mask. Now I'll open the same file in Allsolve. So I have a file with the .gds extension. So once the file is open, we see the settings tab, and under which we see the name of the file that was uploaded. And then we see the units. So a drop down for setting the units. So we have different options: the meter, millimeter, micrometer, and nanometer. So the default is micrometers. So most of the MEMS devices are in micrometers scale. But setting the units here depends on the units in which the GDS file was written in. So for the file that I uploaded, the units in which the GDS file was written is micrometers. So I set the units to micrometers. And below we see that Allsolve has detected the layers with the corresponding numbers. So if we go back to KLayout and see the layer information, we see that we have the same 6 layers and the same layer numbers. And these layers are currently categorized under disabled layers because the .gds has information only about the 2D layout. So it doesn't have enough information yet to build a 3D model from it. So the default state of the layers are disabled. So then we can start adding the layers one by one. So we'll start with the substrate layer. And once we add that, it asks the user to provide the layer thickness. So let's say I provide a thickness of 750 micrometers. And we also see that the Z position is set to 0 micrometer by default. So the first layer is by default has 0 Z position. And on the left hand side, we also see the graphical representation of Z axis, and the arrow indicates the direction in which the subsequent layers would be added. So now if I select layer number 11 and add it, so it is built on top of layer number 63. So now I add the layers subsequently. So after layer 11, it's layer 1, which is followed by layer number 12, and then by layer 2, and finally layer number 23. Now I can start adding providing the thickness information of each layers. So layer number 1 has a thickness of 1 micrometer. And we see that the Z position is calculated automatically depending on the information of the thickness in the previous layers. So layer number 1 has a thickness of 13 micrometer, then 12 has a thickness of 0.25 micrometer, and layer number 2 has a thickness of 30 micrometers, and the final layer has, or the topmost layer has a thickness of 0.1 micrometer. So now I see all the layers that are stacked and all the thickness informations are provided and the corresponding set positions are automatically calculated. I now click on apply and build the model. So we see here a 3D model that was built from the GDS file after providing the necessary thickness information. So this is how you build a 3D model using or importing the GDS file. In many simulation cases, the substrate layer, the lowest layer, is usually not necessary or required. So you can disable layer by clicking this option. So now I apply and build the model without layer number 63. So now we have our 3D model with all the layers except the substrate layer. So now you can proceed to the other part of the simulation, such as creating regions, material properties, and defining the physics that you would like to simulate, the usual process that you would follow for running a simulation. So this is it for the tutorial on working with the GDS file format. Hope this was helpful. See you in the next tutorial.